In contingency tables, we're going to always have at least 2 rows and at least 2 columns. There are at least 2 characteristics that we're going to compare and see if one has any effect on the other. In this case, the table below results from a polygraph experiment in which it was known whether the subject was lying or not. The table indicates when the polygraph test was correct. We're going to use a 0.05 significance level to test the claim that whether a subject lies is independent of what the polygraph test indicates. In other words, we're trying to determine whether or not the polygraph is actually accurate in saying whether somebody's lying or not. If they're lying, then the polygraph should say they're lying, and if they're not, then it should say they're not. If the polygraph is completely ineffective, then it should give the same results to whether somebody is lying or not. Let's take a look at the table values. According to this, the polygraph test indicated that the subject lied when he did not lie 8 times and when he did lie 48 times. The polygraph test indicated that the subject did not lie 19 times when he did not lie and 13 times when he did lie. So it appears to me that it would be more likely to be inaccurate when he lies and the polygraph says that it was not a lie. So let's see what we've got. We'll load this in StatCrunch. Okay, so I can actually, in StatCrunch, I can actually change these column widths. Okay, so I guess that's good enough. So the top row is that the polygraph said he was lying. Second row is polygraph said he didn't lie. First column is that he actually didn't lie. And the second column is that he did indeed lie. The null hypothesis will be saying that whether the subject lies is independent of what the polygraph says. The null hypothesis is that everything's going to be the same, that there is no correlation between what the polygraph says and whether the subject is lying or not. Test statistic. Okay, when we go to stat, tables, contingency, this is with summary. It's already been tallied and put in the boxes. The column headings are that he did not lie or that he lied. Now the row label, because you'll see that there isn't anything in this column at the top of the column here. So I think this blank place is just going to be our row label. Now, the column headings are lied and did not lie. The row label is the blank, because they didn't put anything there. This is a chi-square test for independence of the 2 characteristics. If we have to use our degrees of freedom to find critical values, the degrees of freedom is the number of rows minus 1 times the number of columns minus 1. Just looking at this part, not the totals, but just where the data is. So there are 2 rows minus 1 would be 1. 2 columns minus 1 would be 1. So 1 times 1 gives us 1 degree of freedom. So that's where that came from. So our chi-squared value is 19.0 465, no, 466. Our p-value right here is less than 0.0001, so that's just essentially 0. With our p-value at 0, obviously we're going to reject the null hypothesis. So there is sufficient evidence to warrant rejection of the claim that whether a subject lies is independent of what the polygraph says. The null hypothesis was that whether he's lying or not is independent of what the polygraph says. And basically we have a 0 probability of that. So let's take a look at one problem that actually has more than just 2 columns and 2 rows. And these are not required to have the same number of columns and rows. These just happen to have come out this way. So in soccer, serious fouls result in a penalty kick with 1 kicker and 1 defending goalkeeper. The accompanying table summarizes results from 305 kicks during games among top teams. In the table, jump direction indicates which way the goalkeeper jumped, where the kick direction is from the perspective of the goalkeeper. We're going to use a 0.01 significance level to test the claim that the direction of the kick is independent of the direction of the goalkeeper jump. Do the results support the theory that because the kicks are so fast, goalkeepers have no time to react? So the directions of their jumps are independent of the directions of the kicks. I would hope not. So let's see what happens. I've already loaded this into StatCrunch. So it says the null hypothesis. The null hypothesis would be that everything is independent. So jump direction is dependent, no. Goalkeepers jump, no. Do not jump in there. Just plain jump direction is independent of kick direction. Jump direction is dependent on kick direction. Determine the test statistic. So let's go with stat, tables, contingency, with summary. Our columns, let's go ahead and look at okay, our column headings are left, center, and right. Our row labels, there is no row label that is on the same level with left, center, and right. So I'm going to click that as the blank. Compute. So our test statistic down here, 7.887. Our p-value, 0.094 places, 58. We were looking for a 0.01 significance level. Our p-value is many times larger than that. Therefore, this actually supports the null hypothesis. There is insufficient evidence to warrant rejection of the claim that the direction of the kick is independent of the direction of the goalkeeper jump. The results do not support the theory, or do support the theory, that the kicks are so fast that the goalkeepers cannot react. Wow. All right. So let me know if you have any questions about how to do this. It's really pretty easy, and I will talk to you later.